Yo guys, we're back with Math Paper 3H, and this is part 2 from the June 2011 series. Alright, so question 11a, which is where we left off, is asking you to find, they've given you a table of weight of 80 parcels, and they're asking you to find out an estimate for the total weight of the 80 parcels. Now, if you were normally going to find an estimate for the total weight, you would just take the weight, multiply it by the frequency, and there you have your total weight. But in this case, you have different classes of weight. So you have from 0 to 2, you have from 2 to 4, you have from 4 to 6, 6 to 8, and so on. Okay? And this can be a problem because how do we know which one weighed 0? Maybe one of them weighed 1. Maybe one of them weighed 2. So again, this is why we have to estimate the weight. Okay? So how are we going to do this? So first of all, we know that to find the total weight, we need to take the weight, multiply it by the frequency, and add this to this weight multiplied by this frequency, and so on. But the problem is which weight are we supposed to take? Because it's a range of weights. If you look at it, it's from 0 to 2. So, since we're only being asked to find an estimate, what we're going to do is always take the midpoint of each of those weights. Now, how do we find the midpoint? All you got to do is take the smaller number, add it to the bigger number, and divide it by 2. So it's like 0 plus 2 over 2, which will give you 1. And for this one, it would be 2 plus 4 divided by 2, which would give you 3. So just do it for the rest. I'll just quickly fill that in. Okay, so I've quickly filled it in. So we have the midpoint weights. Now we just have to find the total weight. So all we take is this weight we found, multiplied by this frequency. So 1 multiplied by 8. Then we add it to the next weight, and the being multiplied by the other frequency. So added to 3 multiplied by 14, and this is added to 5 multiplied by 26, and this is added to 7 multiplied by 17, and this is added to 9 times 10, and this is finally added to 11 times 5. So this simplifies to 8 plus 42 plus 130 plus 119 plus 90 plus 55, which will give you an estimate for the total weight to be 444 kilograms. Alright, so for 11b, they're asking you to complete the cumulative frequency table. So how you work with the cumulative frequency table is just basically adding on the frequencies. So what you got to do is for the first one, it's like something I have to show you, I can't just describe it. So for the first table, you add on this frequency you see here, 8. Okay? So for the next range, what you do is you take this amount, 8, so you take the 8 here, and you add on the next frequency, so plus 14. And this will give you a cumulative frequency of 22. And you fill in so on. So the next one should be 22 plus 26, which will give you 48. And then you just fill it out. And so this is a completed table. So question 11c is asking you to draw a cumulative frequency graph for your table. So all you got to do is just plot a simple graph. And on your x-axis you have the weight, which is this, and on the y-axis you have the cumulative frequency, which is this. Alright? But the problem is, again, we have to decide what weight to take, right? Because it's a range of weights, as you can see. So now, in this case, when you're drawing the graph, what you have to take is the upper bound of the weight. So over here, it's just the upper bound, so it's just a higher amount. So for the first point, it's 2 and 8. So we go from 2, and we look for 8, and we plot it. So that's about there. That's 1 point there, right? Then the next one is 4 and 22. So 4 and 22, which is here. Then the next one is 6 and 48, and that is about there. Sorry if it's like a bit untidy. And then we have 8 and 65, which is about there. And then we have 10 and 75, which is there. And then we have 12 and 80, which is there. Sorry, there. Okay, now all we got to do is just draw a line to join all of these points together. Just like that. Again, sorry if my lines Didn't touch. I'm using an iPad, forgive me. So that's basically the graph. So here's an enlarged graph, and it might not be that accurate, but I did my best. Question 11b is asking you to find an estimate for the number of parcels which weighed less than 5.2 kgs. Now this is pretty simple on a cumulative frequency graph. So all we have to do is go to the point of 5.2 kgs, which is around here. We go up towards the graph, we hit the graph, and we go across. Okay, now this is the amount. I think it's about 36, if I'm not mistaken, 36, and everything below this, so everything below 36, is the total amount of parcels which weighed less than 5.2 kgs, because as you can see, like this is all less than 5.2 kgs, this is 5.2 here, everything less than, and this is all the frequencies and stuff like that. So everything less than 36, so it means from 0 to 36, will be the number of parcels which weighed less than 5.2 kgs. So the answer is 36. Again, in the mark scheme, it'll come between a range of 36 to 40. So as long as you have a number or a frequency between there, then you're fine. Okay, so question 12a has given you this diagram, and they're asking you to calculate the length of BC, which is this line here. Now, first of all, I want to introduce this concept called similar triangles. Similar triangles are triangles with the same angles, and so their sides can be compared, the ratios of their sides. So what does that mean? So first of all, I want you to imagine this triangle here being inverted 3D vertically upwards and falling flat on this triangle here. Now, I mean, it's hard to imagine, but what I'm going to say is that these two are similar triangles. And the reason for this is because of the angles. The angles are the same, because these are two parallel lines, and again you have a line going through here and a line going through here. So actually, if you just think about the parallel lines, it suggests that this angle and this angle will be equal, and this angle and this angle will be equal because alternate angles, and these two are equal because they're vertically opposite angles. So what we're saying is that, I mean, just forget that for a second. If you just think about the parallel lines, what we said earlier, this angle and this angle are equal, this angle and this angle are equal, and this angle and this angle are equal. Okay, so now we have to look at the sides which actually correspond to each other in similar triangles. So look at the place where the red and the orange meet. I mean, sorry, just ignore that. So, sorry, let's just start fresh. So we've established what angles correspond to each other and what are equal because of the parallel lines, yeah? Okay, I'm expecting you know your parallel line rules. So that means we know that points B and D correspond. We know that point C corresponds to point C, obviously, and we know that E corresponds to A. So it means that in theory, this side should correspond to this side, and this side should correspond to this side, and finally this side should correspond to this side. And the reason for this is, like, if you look, if you just think about this triangle, this smaller triangle being flipped over so that this angle matches this angle, you'll end up with the same side, you'll end up with understanding the corresponding sides. So now that we've established which sides are corresponding, what happens with similar triangles is that their ratios can actually be compared. So the ratios of this side to this side can be compared, is equal actually to the ratio of this side to this side. So let's just do that. Now we're going to develop a ratio, and we're going to do it from small triangle to big triangle. Okay? So the smaller triangle and is 5.2 is to BC, which is what we want to find out. And also, that means that 6 corresponds to the 9 as well, because these two sides correspond, right? Okay, and if we just put this in algebraic form, we're going to get 5.2 over BC is equal to 6 over 9. Now all we have to do is multiply both sides by 9, divide both sides by 6, and multiply both sides by BC. So I'm just going to skip through this because it's basic algebra. So we're going to get is 5.2 multiplied by 9 over 6 is equal to BC. And so BC is equal to 7.8. Okay, 12b is asking you to calculate the length of CE, which is actually this length over here. Okay, so we're going to develop another ratio again. We're going to do it this time for small triangle to larger triangle. Okay, so now we're going to take the corresponding sides. We're going to use the same corresponding sides we used earlier. So 6 is to 9, right? And we need to find the corresponding side to CE, and that's 7.2. So CE is to 7.2. Now putting that algebraically, we're going to get 6 over 9 is equal to CE over 7.2. And so CE is equal to 6 times 7.2 over 9, and that is 4.8 centimeters. Okay, question 13, pretty simple again. All they're asking you to solve this equation. Now, we've done this before. We've done that like you can't just add these two fractions together because they don't have the same denominator. So what we're going to do is we're going to develop the same denominator. Now we're going to do that technique called cross multiplication, which we discussed earlier, where you multiply this by the opposite side and this by the opposite side, and then you multiply them both out. Sorry for the little scribble there. So let's start off with the 5. So you multiply the 5 by the 2x minus 1, and then you multiply the 4 by the x minus 1, right? And then you get a total denominator by multiplication of these two numbers together. So 4 multiplied by 5. And this is just a technique to use to develop to get a common denominator. Alright, so now we have, let's just expand this out quickly, and this too, and then multiply both sides by, sorry, this is actually 2, I made a mistake. Yeah, so what we're going to get is 10x minus 5 plus 4x minus 4 is equal to 2 multiplied by 20, because this is equal to 20, right? And you just multiply both sides by 20. So simplified, this becomes 14x minus 9 is equal to 40, right? Now if you add 9 to both sides, you get 14x is equal to 49. You divide both sides by 14, you're going to get x is equal to 49 over 14, which is equal to 3.5. Okay, so question 14, they've given you y is equal to 1.8 correct to 1 decimal place. Calculate the lower bound for the value of 4y plus 1. So first of all, I'm going to introduce you upper bounds and lower bounds. So when you round something off, so for example, you have 1.8 and it's rounded off to 1 decimal place. That means that it could have been either 75 rounded up, or it could have been 1.849999 rounded down, or 1.85. That's just like the same thing, right? So it could have been either 1.8499 or 1.85 rounded down, or 1.75 rounded up, okay? So what happens is the lower bound is just the 1.75 and 1.85 is the upper bound. Pretty simple. Now a way of calculating the upper and lower bound is you just take the amount it was rounded up to, so it's 1 decimal place. So in this case 1 decimal place is 0.1, correct? And you just divide this by 2 and you'll get 0.05. Now what you do when you have 0.05 is when you want to find your lower bound, you just take the original number, subtract this number. If you want to find the upper bound, you just add this number. Okay? So that's pretty simple. Now, in this question, they want us to calculate the lower bound of 4y plus 1. So that means they want a lower value. They want a lower value in general. So that means what we need is we need the lower bound of 1.8. So 1.8 has been rounded to 1 decimal place. So 0.1 divided by 2, which is 0.05. Now, we want to find the lower bound because we want to find lower bound of this total value. So what we do is we just we multiply it by the lowest number possible, basically. We multiplied by the lower bound. So 4 multiplied by the lower bound of y. So it becomes 1.8 minus 0.05, and so the lower bound of that is just 1.75. Okay? So now we do 4 multiplied by 1.75 plus 1. And so that becomes 8. Alright, question 15a is asking you to find the area of the shape. Now, if you really look at the shape, you'll notice that it can be divided into two separate parts. I'll call them A and B. And in A, it's nothing but a rectangle, and B is a semicircle, okay, with a radius of 2.7, as they say in the question. So, all we have to do is find the area of A, find the area of B, add it together, and boom, we have our total area. So, first of all, let's deal with A. So we have the length of A, and we all know that the area of a rectangle, I'll draw a rectangle, is equal to length times width, which is equal to 7.1 multiplied by the width. But what is the width? Now if you just look at this semicircle over here, the radius is 2.7. And since it's a semicircle, that means this can also be the radius, and this can also be the radius. Correct? So, the total, and if you just join those two lines together, you'll notice that it becomes the width of the rectangle. So you just have to do 2.7 times 2 to find the width. So multiplied by 2.7 multiplied by 2. And that'll give you the area of A, and that is 38.34. Now, let's deal with B. Sorry, I'll draw that again. Now B is a semicircle, right? So the area of any semicircle, a semicircle is basically a sector, so we'll just draw like a sector, is equal to the angle of the sector, and in this case the angle is 180, over 360, because the total circle is actually 360 degrees, multiplied by pi r squared, the area of any circle. And in this case, r is actually 2.7. So yeah, so it's 180 over 360 times pi times 2.7 squared. Put this on your calculator and you're going to get an answer of 11.45, and I've rounded off to 4 significant figures. Now all you have to do in the end to find the total area, TA, is equal to 38.34A, basically A, plus 11.45, and that is 49.79, which is just 49.8. Okay, question 15b, they've distracted you with this whole shape and everything. The real question is they've just given you this formula and they're asking you to make R the subject of the formula. So that is really easy. So first of all, what we're going to do is actually, we have R over here, we have R over here. We could have factorized this, but in this case we can't factorize because there's an L over there, and that has no R. So that means we can't factorize it. So first of all, we got to get rid of this stupid L, which is screwing everything up. So what we're going to do is we're going to subtract 2L on both sides. So subtract 2L. And we're going to get P minus 2L is equal to pi R plus 2R. Now notice we have the R's on one side and we have the stupid other things on the other side. So all we have to do is factorize out the R. So we're first going to write P minus 2L equals R. We factorize it out. Pi R divided by R is pi, and 2R divided by R is 2. So there it is. Now we're just going to divide both sides by pi plus 2 to get R alone. So that cancels out, and in the end we end up with R is equal to P minus 2L over pi plus 2. And that way R is the subject. Okay, so question 16 is about circle properties. I'm not going to explain the circle properties because that would take too much time. You can just look online, it'll be pretty simple, and yeah, or in your textbook. So first of all, I'm just going to state the circle property and that's it. So in the first question, 16a1, they're asking you to calculate the size of angle AOB, which is that angle over there. Now, if you notice, there's one triangle here, and there's one triangle here. And as you can see, they're both in the same arc. Now, there is a rule that states that the two triangles in the same arc, so there's this rule, I'm just going to say it. If there's two triangles in the same arc and one just goes to the center, right? That means that the angle at the center is actually twice the angle at the edge or at the circumference of the circle. So AOB, angle AOB, is just simply 2 multiplied by 57 degrees. And that is just 114 degrees. Because the angle, and the reason for this, which is asked in 16A2, and the reason for this is that the angle at the center is twice the angle at the circumference. So just say angle, I'm just going to write it quickly, center twice angle at circumference. Scribble. Okay, so the angle at the center is twice the angle of the circumference, provided that they're in the same arc. Okay, question 16b is asking you to find angle BAD, meaning this angle over here. So, simply, if you notice, this actually forms a cyclic quadrilateral. Now, a cyclic quadrilateral is actually a quadrilateral where there's 4 sides and each edge touches the circumference. So each vertex touches the circumference. So what happens in a cyclic quadrilateral is that opposite angles actually add up to 180 degrees. So this and this is opposite. So that means that not AOB, this time it's BAD, angle BAD is equal to 180 minus 106. And so that is 74 degrees. Okay, thanks guys, we're done with this part. Please go on to watch part 3. And please comment, rate, and also subscribe. Like, it would mean a lot. It's just one click of a button and it would help me a load. So I'll see you on the next video, and if you have any questions, comment and rate also. Thank you so much. Bye.